Good morning and welcome to the video on rational exponents and radicals. When we talk about radicals, what we're actually talking about is roots, and you're pretty familiar with square roots, but there are other kinds of roots as well. So for example, some of you might be familiar with, if I wrote this, the square root of 4 equals 2. And the reason it equals 2 is because that's b/c, because 2 squared equals 4. We can have other kinds of roots as well. For example, we could have the cube root of 8. That also equals 2. And the reason why is because 2 to the third power equals 8. So here's what I want you to notice about this, is that everything matches up here. Let me put a pointer on so you can see this. Let's see if I got a pointer here today. Nope, no pointer yet. Bear with me. There we go. Nice pointer. So see here, this 2, cube root of 8 equals 2, 2. This is a cube root, third root to the third. Cube root of 8, 2 to the third equals 8. And that's kind of how these roots work and why they're related to the exponents that we've been talking about in this unit. So one thing I want to point out to you is the different parts of what we call a radical. And one thing that's really important here is this little number right here is what we call the index, and it tells us what kind of root it is. Now if you notice down here I have a 3, so it's a cube root, which means I'm looking at something cubed, but you notice this one doesn't have one. If you don't see one, what it really is a 2. So this is a second root, or a square root we call it, if you don't see one. So you have the option when you're doing square roots, you can write the 2 or you can skip writing the 2, either way. All right, this little line here with the little angles in it is called a radical sign, and this underneath here is called the radicand. The radicand. All right, so this is what we're going to be talking about in this unit. On this screen, we're going to find some simple radicals, and I'm going to give you a list of ones that I feel like you should probably remember. This is like your Algebra 1 multiplication table memorization chart. So I'm going to tell you which ones to memorize, but we're going to go through a few of them right here. So first of all, A is the cube root of 125, and let me tell you that that is going to be 5. And the reason why is because 5 to the third equals 125. Now, this one is the fourth root of 16. I will tell you that equals 2, and the reason why is because 2 to the fourth equals 16. So 2 multiplied by itself 4 times equals 16. Here I've got cube root of 27. This equals 3, and the reason why is because 3 to the third equals 27. Fifth root of 32. You should actually know this one by heart after this lesson, is 2, and the reason why is because 2 to the fifth power equals 32. Cube root of 64 is 4, and the reason why is because 4 to the third power equals 64. Next one, notice we do see the little 2. This is the square root of 36, which you can also write without the 2, just like this. Square root of 36 is 6, and the reason why is because 6 squared equals 36. On this screen, I've got a list of all the radicals that I think you should know by heart. When I write the test, these are the ones I am going to pull from. And so you can see in the very first column here is I have all of the square roots all the way from square root of 1 up to the square root of 225. Now, if you notice, there's nothing here between a square root of 16 and square root of 25, and the reason why is because their answers are 4 and 5, and what's between 4 and 5 is decimals and fractions, and we're not going to deal with those. So you'll see that these are the ones that I need you to know. And for example, the reason, here we go, that the square root of 69 equals 13 is because 13 squared equals 169. Now, I also have some cube roots that I want you to know. And here are the cube roots. Cube root of 1, cube root of 8, 27, 64, and 125. Cube root of 125 is 5 because 5 to the third power equals 125. I've got a couple fourth roots I want you to know. Fourth root of 1, 16, and 81. And we've got fifth root of 1 and fifth root of 32, which equals 5. Well, that's wrong. Let's fix that right now. Let's scratch that out. That equals 2. It might be a good idea to pause the video right now, look at the screen, and copy these down on the back side of that note card that we've been working on in class. What I'm going to show you on this screen is maybe a little bit more challenging. We're going to add 2 new rules to our note card when we come in. I don't have my note card here at home, so I can't help you do it from home. And those 2 rules are right here. We have a to the 1 over n power really means the nth root of a. So now you're finding out that when we have fractions as exponents, that really means roots. And that's why the roots fit in so well with this particular exponent unit. The other one that we're going to have is a to the m over n power equals, and we can write this 2 different ways, and you can choose which one works for you. You can write it as the nth root of a to the m power, or the nth root of a in parentheses raised to the m power. And I'm going to show you when that's going to be beneficial to you. What we're going to do on this particular page is we are going to rewrite these in what we call radical form. So radical form, let's underline that, is when we make it look like this. All right? So all we're doing is taking our exponential form, which is this, and rewriting it in radical form. Okay, first one. Keep in mind that whatever number is in your denominator of your fraction, that's the kind of root that you are going to have. So we can rewrite this as the 6th root of a to the 5th power. So now we've rewritten that in radical form. Let's go over here to example B. The one thing we have to keep in mind is that 1/3 power only belongs to the x, not to the 5, because there are no parentheses. So this is 5, and then it's a cube root because the 3 is on the bottom, so cube root of x. And it's x to the 1 power. We don't need to write the 1 power. So let's go ahead and go down here to example C. This is going to be the same type of situation. The exponent only goes to the a, not to the 12. So the 12 stays out in front. And this becomes the cube root, because the 3 is on the bottom, of a squared. So that numerator is going to end up going right here in your radicand. Now, this next one is kind of tricky. And I'm going to show it to you 2 ways. And I want you to do an assessment of yourself and try to ask yourself what kind of student you are. Here's what I expect everybody to be able to do. Now, this time there are parentheses, right? Do you see the parentheses? So now this is the 5th root of, and the whole thing goes in here, 64a. Put it in parentheses still, and it's raised to the 4th power. However, this can be simplified, and I do expect some of you to be able to do this. If you're an 8th grader wanting to go to Algebra 2 next year, you need to be one of the people doing this. If you are ever in the 100 club, I expect you to be able to do this. So let me show you another way to simplify this further. Okay, you'll see that I've written 64a as 32 times 2a. And the reason why I'm doing this is because the 5 in my denominator tells me I'm looking for a 5th root. And guess what? on my list of roots I need to know is the fifth root of 32. I can simplify that. So I'm going to look to pull that out. And so the way I'm going to rewrite this using my laws of exponents is 32 to the 4/5 power times 2a to the 4/5 power. Now let's watch. We've got to simplify this 32 to the 4/5 power. And what I'm going to do is use this part right here. I know the fifth root of 32. So I'm going to write fifth root of 32 because I know what that is. I'm going to put it in parentheses, raised to the 4th power. And over here, I'm going to write fifth root. Put this in parentheses, 2a raised to the 4th power. Now, go back here. Fifth root of 32 is 2. So this is 2 to the 4th. And then just bring this down. Fifth root of 2a in parentheses to the 4th. 2 to the 4th right here at the beginning is 16. And then we're going to multiply it times the fifth root of, and you can leave it the way it is, or you can write this as 16, because that's what 2 to the 4th is, a to the 4th. Okay, the next thing we're going to do is we are going to take something that is in exponential, or I'm sorry, in radical form and convert it to exponential form. So I want to show you this right here. Whoops, I've got highlighter on and I don't want that. I would like a pen. Thank you so much. This right here is exponential form. So you'll see that what I had is in radical form, and I'm going to write it in exponential form. So let me switch back here to blue. And remember, whatever the root is, it's a fifth root here, that 5 goes in the denominator. So this, when I simplify it, is going to be b. Whoops, I'm sorry, the 5 goes in the denominator. Let's back that off. Go to the eraser. We can do this. All right, 3/5 power, because that 5 has to go in the denominator because it is a fifth root. Go over here to example B, and we've got, it's a cube root. The 3 goes to the denominator. So this is going to be s to the 2/3 power. Okay, let's go to example C. C, we've got a 12 out front. So we're just going to write it like this, 12. And then we have x. This is a cube root, so the 3 goes to the bottom. So this is to the 4/3 power. Whoops, 4/4. Gosh, I'm all over the place today. Let's erase that off. Fix it. 4/3 power. Okay, now the last two are a little bit more difficult. Once again, if you're that student who should be doing the more difficult problems, as I mentioned before, you need to be able to do a problem like this. So, first thing I'm going to do here is I'm going to write this in okay, so this is going to be 27 to the 1/3 power, because the 27 only has an exponent of 1, and the d is to the 5/3 power. Now, if you recall from one of our last units, we know 27 to the 1/3 power is what multiplied by itself 3 times gives you 27, and that is 3. So this is 3d to the 5/3 power. Now let's take a look at example D, and if we go to this one right here, it's in parentheses, so this is 4y, and if you look, this is a square root. There's no 2 there, but they don't need to write a 2. This is a square root to the 5/2 power. All right, and so if we use our rules of exponents, we can write this like this: 4 to the 5/2 power, and we can write y to the 5/2 power. Now, if you recall, what we learned in our last unit was that we can rewrite this 4 to the 5/2 5 times. 4 to the 1/2 times 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 4 to the 1/2. And finally, let's fit it in here, y to the 5/2. Now, each of these 4 to the 1/2, really 4 to the 1/2 power means what multiplied by itself 2 times gives you 4, and that is 2. 2, 2, 2, and 2. And 2 multiplied by itself 5 times gives you 32 y to the 5/2 power.